Okay, this is part one of a screencast covering life in the universe, both in the solar system and beyond, perhaps past and present. Okay, within the solar system, there are perhaps four good places to look for evidence of currently having life, or at least sometime in the past, maybe having had life. Okay, the first and most obvious place to look would be the planet Mars. Planet Mars today is extremely cold and dry, and it has an extremely thin atmosphere. So the possibility of life existing on Mars right now is pretty remote. However, in the past, we do know that Mars was once warm and wet, similar to the Earth. This has been confirmed, for example, by the various space probe missions, landers, orbiters, and rovers that we have sent to Mars over the last couple of decades. Hey, here's a nice aerial photograph of some ancient riverbeds on Mars that were formed by liquid water flowing on the surface. Whether or not liquid water in some form still flows on the surface today, or maybe exists just below the surface, is still somewhat of an open question. There is some evidence to suggest that in a very briny or salty form, there may still be limited flows of water at the surface of Mars. These channels here, for example, show evidence of that, but the evidence, as far as I understand it, is rather fragmentary. So whether or not Mars actually has liquid water on its surface right now is probably pretty doubtful, at least in any sizable form. But in the past, Mars was definitely warm and wet and may have supported life. We probably won't be able to definitively answer these questions about Mars, however, that is, whether or not it actually contains life today or it has fossilized remains of life in the past, until we actually go there and dig with shovels. There have, however, been some intriguing hints over the years that Mars is definitely the place to look. So, for example, this right here is a very famous photograph of the interior of a Martian meteorite that was found in Antarctica in 1994. Okay, now, how could a piece of Mars actually make it to the Earth as a meteorite? Well, imagine millions of years ago an asteroid striking the surface of Mars, and then ejecta or debris is ejected off of the surface of Mars itself. It then slowly makes its way to the Earth over perhaps a few million years and eventually crashes on the Earth as a meteorite. This sounds pretty unlikely, but we actually have had, I think, about a dozen examples of meteorites found at the surface of the Earth that definitely came from Mars. This right here is an electron micrograph of the interior of one of them that was found in Antarctica in 1994. Now, when you look at a photograph such as this, you say to yourself, okay, game over. Right there, this is definitive proof that there was, at least in the past, once life on Mars. This definitely looks like a fossilized bacteria. However, it turns out that an object like this can be formed naturally by mineral deposits that have nothing to do with life. And this electron micrograph of this object that you're looking at here, well, the object itself is much smaller than an Earth bacteria or even an Earth virus. So whether or not this is the fossilized remains of microbial life from Mars is still considered to be an open question, but most people doubt it. At any rate, however, as I said, with respect to Mars, we really won't be able to definitively answer whether or not Mars had life in the past or has life today until we go there and dig with shovels. The next rover mission to be launched to Mars, I believe in a year or so, is going to specifically look for evidence of past life. At any rate, however, moving on from there. It turns out that one of Jupiter's moons, the moon Europa, which is slightly larger than the Earth's moon, may actually be the best place to look for currently having life here in the solar system. Okay, the surface of Europa is made up of water ice, and the surface itself is extremely young. The reason why we know that it's young is that there are little to no impact craters that are present on Europa. And then organic material, all this brown stuff that you see right here, for example, is actually seeping up from cracks within the moon's interior. That is through the water ice itself. Okay, this right here is a very nice close-up of the surface of Europa. This particular photograph was taken by the Galileo space mission from the 1990s, which studied the Jupiter system extensively. At any rate, however, basically what you're looking at here is a photograph of broken up icebergs that are floating on a liquid water ocean. We know that that liquid water ocean is there from a photograph such as this, and we also know that it's there because of the magnetic field that it generates, and it's the magnetic field signature associated with a salty or briny ocean. The heat source that is present within Europa that is causing all this activity at the surface is tidal flexing. As Europa orbits Jupiter, it's gravitationally pulled on by Jupiter and by the other moons of the Jupiter system. All of that flexing then generates heat in this moon's interior. So you basically have all the ingredients for life that are now present here on Europa. You have a heat source, you have liquid water, and you have organic molecules. Now, what might actually exist at the bottom of the ocean, for example, of Europa? Perhaps something like this. This right here is a photograph of the ocean floor here at the Earth. And what you're looking at here is a colony or an ecosystem of organisms surrounding this material right here. This is referred to as a black smoker. Black smokers basically occur at divergent plate boundaries at the ocean floor here on Earth. These are basically sections of the Earth's crust that are moving apart, and then molten material, heat, and minerals then basically bubble up from within the Earth's interior, resulting in these huge chimneys or columns of smoke, if you will, that are emerging from the interior of the Earth. These are referred to as black smokers. At any rate, however, look at all of this stuff right here. This is basically an ecosystem of organisms that are using all this material and all of this heat as their raw materials for the processes of life. So these ecosystems survive on what is called chemosynthesis. That's basically using heat from the Earth's interior and all of these minerals here as raw material for the processes of life, as opposed to, say, photosynthesis here at the Earth's surface. So the reason why I mention all of this is because it's probably a pretty good bet that there is something like this on the ocean floor of Europa. In order to basically answer that question, however, NASA eventually plans to send a probe to Europa to perhaps land on the surface, melt through the ice in some manner, and then maybe send a submarine down into the liquid water ocean below. I think it's a pretty good bet that there is life on Europa. I think it's a pretty good bet that that life may be as advanced as these ecosystems here that we have on Earth. All right, moving on from there. Okay, now we get to two moons in the outer solar system, specifically orbiting the planet Saturn. First, here is the moon Titan. Titan is the largest moon in the solar system. It's actually larger than the planet Mercury, and it's also the only moon in the solar system that possesses a sizable atmosphere. The atmosphere of Titan is basically made of methane and ethane, natural gases, and the thickness of the Titanian atmosphere is actually several times thicker than the Earth's atmosphere. Titan is basically a version of a primordial Earth. We think that Earth was like this billions of years ago before life began to form on Earth, but the difference between Titan and the Earth is that Titan is extremely cold. However, there are all of these organic molecules that are present here on Titan, specifically ethane and methane. We actually have sent a probe to the surface of Titan. This was part of the Cassini mission from about 10 odd years or so ago. A portion of that mission was called Huygens. The Huygens probe actually soft landed on Titan. Excuse me. Okay, let me show you a couple of photographs from that portion of the mission. Okay, this is an aerial photograph of the surface of Titan as the Huygens probe was descending to the surface. Titan has what is called a hydrologic cycle that is similar to that of the Earth. With respect to the Earth, however, the liquid that goes through this cycle is liquid water. Liquid water rains onto the surface of the Earth. It drains through rivers and streams and eventually makes its way out into the ocean, where it evaporates once again to begin the cycle anew. The same thing is happening on Titan, but it's not happening with liquid water. Instead, it's happening with methane and ethane. So what you're looking at here is an aerial photograph of some hills here of Titan as the probe is descending. And take a look here off to the side. You can see right here what are river channels. These river channels right here are not river channels of liquid water, but instead liquid methane and ethane. Titan is the only other place in the solar system other than the Earth to actually have bodies of liquid at its surface. But the bodies of liquid at the surface of Titan are not liquid water, for example, as it is here on Earth. Instead, we have lakes and shallow seas of methane and ethane. So you have all of this organic material that is present there. It is extremely cold, but there is a heat source. Titan is large enough to generate heat in its interior, and it's basically providing the energy for all of these processes. This right here is also from the Huygens probe. This is the only photograph that we have of the actual surface of Titan. The rocks that you see right here in the foreground, for example, are actually not silicate rocks like rocks here on Earth. Instead, they are rocks of water ice. Okay, and then the last moon in the solar system, if you will, that's a good place to look for life is a tiny moon of Saturn. This is Enceladus. Enceladus is pretty small. It's only about as big as Texas, but it's very highly reflective, and you can see that it has a water ice surface. Take a look at these geological features down here. Notice that there are no craters present, so this portion of the moon, its surface is very young. These features right here, by the way, are referred to as tiger stripes. Guess what is emerging from the tiger stripes? Liquid water geysers. And we have found organic materials to be present within these liquid water geysers. So you've got this really tiny moon here, basically the edge of the solar system. It has a heat source in its interior that's generating all of this activity. It has liquid water and it has organic molecules. So it might be a pretty good bet that there might be some form of primitive life here on Enceladus. So you basically have four places right off the bat within the solar system other than the Earth where it is a pretty good bet that life existed in the past or perhaps exists today. Okay, let me conclude this as part one of this screencast.